Across the universe, from distant gas clouds to the heart of life on Earth, the chemical properties of one element weave a story of unimaginable complexity and beauty. Carbon. Carbon's need for 4 covalent bonds means that its molecules easily form long chains, and they provide a scaffold for life itself. Organic chemistry is the term that chemists use to talk about any compound based on chains of carbon atoms or those with carbon-hydrogen covalent bonds. They are everywhere, and they are fundamental to life on Earth. They're in the food we eat, the scents we smell, even the very cells that make us who we are. We call it organic chemistry precisely because life on Earth is based upon chains of carbon atoms, often joined together with hydrogen, oxygen, and approximately 25 other elements. The complexity of how they combine is vast, with some molecules containing well over 500,000 individual atoms. And all of these compounds require a name. When chemists name these compounds, we seek 2 things. First, a uniform name that can be agreed upon across all nations. And second, a structure so that the name, when you hear it, can help you convert it into the compound's correct chemical structure. Now, we can't explain all of organic chemistry in a single breath. It's simply too vast. So instead, we group similar compounds into what we call homologous series. That is, families of molecules that behave in similar ways because they share a common structure. Let's begin with the simplest series of them all, the alkanes. These molecules are actually part of a wider group of compounds we call hydrocarbons. Hydrocarbons are molecules made of only 2 elements: hydrogen, carbon, and nothing else. In the alkane homologous series, the atoms are linked together by individual single covalent bonds, with hydrogen atoms completing their structures. Each carbon atom requires 4 covalent bonds to reach a chemically stable state. So let's start by meeting the smallest of these molecules, methane. This is methane, CH4. And we start with our single carbon atom and then provide hydrogens to complete its 4 bonds. And that's it. We're done. We can assemble more examples like this by adding 1 carbon after the other onto the end of that chain. In the simplest chains, there is only 1 single straight line of carbon atoms, with the bonds around the outside of the chain being completed with hydrogens. So we now have a series of molecules that look like this. And our next job is to name them. Here, we're fortunate that there is an internationally recognised body that directs the naming of chemical compounds. That is the International Union of Pure and Applied Chemistry, which is generally just known as IUPAC. And their rules are pretty straightforward, at least for simple chains of atoms like these. Now, the name always starts with a prefix, linked to the number of carbon atoms. For example, this chain has 5 carbon atoms, so starts with the prefix pent. That's actually linked to the ancient Greek word for the number 5. You'll know this from pentagons in maths and pentathlons in the world of sport. To indicate that this is a simple alkane, we just add ANE on the end of its name. and then this molecule's name becomes pentane. The next 5 all have a similar structure with Greek prefixes and ANE on the end. Even at A level, you'll be unlikely to meet anything longer than decane, that is 10 carbon atoms. But here are a few more if you're interested. The smaller molecules don't have Greek prefixes. Now, we've already met methane, and meth is the prefix for 1 carbon atom. The next 3 are eth for 2, prop for 3, and bute for 4. Now, these could be a bit tricky to remember, but fortunately there are a few little popular mnemonics to help us. My personal favourite is monkeys eat peeled bananas, to get meth, eth, prop and bute in that series stuck in my head. So here's butane, propane and ethane. And of course we've got methane, which we've already met. Now, instead of drawing the full molecule out each time, what we call its structural formula, we often use its molecular formula. And here's how the first few look. Methane, CH4, ethane, C₂H6, and propane, C₃H8. So, what if I'm asked to write the chemical formula for hexane? Now, I don't really want to have to draw it out and count all the atoms every time. That's far too much like hard work. Fortunately, there's a pattern that you might have already spotted. You see, each carbon atom has 2 hydrogens attached, and the ones on the end have a 3rd hydrogen to fill up that last bond. This means that mathematically, all we need to do is count up the number of carbons and double it, and then add 2 onto that number to complete our number of hydrogens. As a general formula, we therefore get this: CₙH₂ plus 2. In the UK, most exam boards will expect you to be able to name the first 5 to 10 alkanes, recognise their molecular structures and formulae. And they'll ask you to be able to calculate the missing number of carbons and hydrogens. Here are a few examples. Draw the structural formula for butane. Okay, well, bute means 4, so there's 4 carbon atoms, and we add in the hydrogens, check every carbon has 4 completed bonds, and we're done. This is butane. Name the alkane C₃H8. All right, I've got 3 carbons, so it's meth, eth, prop, add ANE on the end, and I've got propane. What about completing this molecular formula? Okay, so I'm going to use CnH2n plus 2. First of all, I'm going to take the 8 and double it to get 16. I'm going to add 2 on, and then of course I've now got C₃H18. If you want some support with this, I've produced the worksheet which has loads of examples. It's downloadable from my Patreon page, and that is linked below. And this is as far as you need to go on most GCSE courses. For A-level students, there is another video that covers what happens when the chains of carbon atoms branch, like this. For GCSE students, the next step is looking at the chemical reactions of the alkanes and how they change as the carbon chains get longer, and that video will be linked below just as soon as it's ready to upload. Please drop me a comment below, let me know whether this has been helpful to you, ask any questions that you want, and if you want to request a specific video on something that's important to you, just let me know. I really do value your comments and support. Remember to like and subscribe, and I'll see you in the next video. Bye-bye.